Hi, I'm Paul Merrill, and I'm here to talk today about 6 helpful practices for test automation development. Hope you enjoy this recording. Hello, my name is Paul Merrill. I'm from Beaufort Fairmont Automated Testing Services, and I'm here today to talk about 6 helpful practices for test automation development. If you're listening to this recording, you probably know who we are or who I am. I'm Principal Software Engineer in Test at Beaufort Fairmont. I'm also the founder of the company. We are located in Cary, North Carolina, and we like helping out companies and helping them solve 2 basic problems. Problem number 1 is the idea of in agile testing, in agile development systems, we have developers and testers that often are out of sync, and we know how to sync those up within sprints. So the testing is doing at or before the time that development is getting done, so that we can get things out to market quicker. We don't have a lag time of testing several sprints behind development work. Second thing we like to do is to help teams actually automate their regression. We can do that at any level. If you're new to test automation, or if you've been doing it for a while, we can help you out with some skills that we've learned over a lot of different years. Once again, my name is Paul. This is my Twitter handle here, dpaulmerrill. Make sure to follow me on there. I'm presenting this for the first time, recording it here on the 22nd of March in 2017. You'll be looking at this in the future. So here are a few things that are coming down the road here soon for us. TriAgile is a nice local agile conference. It got about 700 people at it last year, and that will be happening next week here in the Raleigh-Durham, Chapel Hill Research Triangle area. So make sure to put that on your calendars if you're around. It's a really good price for what you get out of it. A lot of local leaders within the Agile community come out and speak and join us, and we just have a lot of really great people at that can teach you a lot and that you can help learn from. Quality Jam will be going on in Atlanta in Georgia, the 18th and 19th, just a few weeks away from now, and I'll be out there speaking about machine learning and testing and whether or not machine learning and AI will take over testing jobs. So if you're interested in that, join us. I have a few discount codes. If you want to reach out to me, they're on Twitter, dpaulmerrill, or through my email address, paul@beaufortfairmont.com. The next webinar is going to be on the 24th. I haven't got a title for it yet or a name, so if you have ideas, let me know. If there's ever anything you want to know about these or topics that you want to suggest, please shoot them to me over one of those channels. So today we're going to talk about patterns. I thought we'd start off talking about sequences. So what is the next number in each one of these sequences? Hopefully this is a little fun game for us to get started here. You know, that first one, maybe that's not too much of a challenge, and who knows about the second one. Third one's a little different. That fourth one's quite a bit different. So if you've got those, hopefully you've solved them. If you need more time, just pause it right now because I'm about to, spoiler alert, I'm about to bring the answers in here. So pause it if you're still thinking. And these are what they are. So the first one are even numbers. So the next digits would be 8 and 10. The second one is the Fibonacci sequence, which means that we're going to take the previous 2 values, add them together to get the next value, so we can predict the next value that way. 1 and 1 equals 2, 1 and 2 equals 3, 3 and 5 equals 8, and so on. The next one is primes, so that was a little more difficult. We can't necessarily predict the next prime, but if we look at the numbers that we're given and we think about what they are, we may be able to tell what the next number is. I don't know, what was the sequence that I gave you? If I gave you a 2, 3, 5, 7, and 11, then you might have an idea. But you really need to skip over that 9 to know that this is not odd numbers in that one, right? So, so that's a little more tricky. And then the digits of pi was the last one. So 3.141592, etc. The way that you get pi is there's a formula to it. You divide the circumference of a circle by the diameter, and you get pi. But if you don't know that formula and you don't recognize the numbers, you can't predict what the next number is going to be. So which ones of these are patterns? That's my question to you. We're going to talk about patterns. have a formula for. We just know that the number is divisible by 1 in itself and nothing else. And so the formula there we don't really have, but by looking at the nature of the numbers, we may be able to predict the next one with knowledge outside of that sequence. So that's important to think about in this. Is it really a pattern if we have to have knowledge outside of the sequence? The digits of pi, if you know that formula, circumference divided by diameter, then you can predict out the digits when you do long division. And of course, this is why all third graders all across the world hate long division, because some numbers just keep dividing. So what is a pattern? What's a pattern to you? What does it mean to be a pattern? It's something that's predictable. It's something that we can look at the past and see what the future is going to look like. It's something that we've seen over and over again in time, something that we're familiar with and we will be familiar with in the future. I looked up the definition. This is the one from World English Dictionary, and their definition of a pattern is an arrangement of repeated, sorry, I forgot to turn off my phone here. It is an arrangement of repeated or corresponding parts, decorative motifs, etc. And I always love it when a definition has the word etc. in it. That's really descriptive and helpful, isn't it? But the example here is, although the notes seemed random, a careful listener could detect a pattern. So this is something where we see things repeated. You know, as I look back over my experience and over my career, I see patterns in the things that I've done, and those patterns come about because I've got concrete experience. So I've actually gone and done something. I've done lots and lots of test automation with lots of different companies. And each time I go in, I want to understand what's going on with the testing culture, what's going on with the organization, and then actually get in and get my hands dirty and understand, like, how are we doing this? Why are we doing it? All those types of things. But without that concrete experience, I don't necessarily have a bed of experience to reflect on. So there's a second part of this, which is reflecting back on your experience in order to gain something out of that experience. And by that reflection, sometimes you come to abstract conceptualization, and from that you may go back to challenge those concepts and to challenge those abstractions with active experimentation. If I do this, do I get the same results when I assume that the world works through this model that I'm looking through today? Will my hypothesis be concluded to be correct if I do such and such? How can I challenge that hypothesis? That's the active experimentation part. And over the course of my lifetime, I tend to get stuck in reflection and abstraction. If I could do two things for all of my time, I would do those two things. I just sit back and abstract on things and reflect on things. But the fact is, without the concrete experience and without the experimentation, you don't know how to do the other things. You don't have the raw materials that you need, those experiences, the experimentation, the results of those things, in order to go back and reflect on them and to get something out of it, these abstractions. So all of these pieces are important, and over my career I've had the opportunity with many different teams to look at test automation and get that concrete experience and figure things out. I think one of the things that tends to be lost with test automation is that we don't have enough experience as test automation engineers to reflect on those experiences and get some type of abstraction out of it, to understand the why and the principle of the things. Many people are not at that point yet, and we've had the fortune here at Beaufort Fairmont to get a lot of folks who've got lots of experience and can share that with you. But these ideas of these patterns came right out of Cobb's theory there. We practiced that many times over. So I want to talk about these. Number one, isolate test cases. So when we're writing test automation, one of the things that I see again and again is that whether we know it or not, we tend to write test cases that are dependent on one another. And when we do that, we suffer a certain fate. And that is that one automated test, if it fails, and another is dependent on it, both of those two tests have the potential to fail. I think of situations like going into a system and creating a new user, and then in a second test, using that user that you just created to modify user properties, and then in the third test going in and unmodifying those properties to see if it works. Well, if the first test fails, the second two are going to fail. If the second one fails, the third one's going to fail. If the third one fails, you don't know if it failed for good reasons or not. So these are the places where I would say let's isolate test cases. I spent a lot of time last year in 2016 as one of my bigger learning objectives throughout the year to look at why it is that we want to do isolation of test cases. What is it that's really behind it? And what I found and what I realized over time is that, you know, there is one main reason that we have problems with test cases that are dependent on each other. And the thing that causes those problems is not that we're dependent on the actual test case or the execution of a test case. It's that we've got contention over a resource, and that resource is generally data. Many times it's data. It's not always data. It may be another system. It may be a resource of another kind, a file system. It may be a third-party API, but we've got some dependency outside of our test case that we're depending on. And when we've got that contention on that resource, we can't do parallelization. We'll end up with a race condition. So if we have those three test cases that I mentioned earlier, test case 1, test case 2, and test case 3, if we're all using the same data that test case 1 created, test case 2 modified, test case 3 is unsetting, we're going to have problems. We're all contending on that same user profile and the properties related to that user profile. There are several ways to go back and deal with this, and I talk about this a lot in some other webinars that I've done. You can find beaufortfairmont.com/webinars. You can find some of those. One of them is called Patterns in Test Case Management or something along those lines. One of them is called a demo of test case data management or data strategies. But if you look for the word patterns, and if you look for test data on beaufortfairmont.com/webinars, you'll find those two webinars. Make sure to go back and look at those, because I go into this in more depth. But we really only have a couple different options for how we're going to deal with these resources that our test cases are all bound to. One option is that we could make sure between test cases to reset that data and put it back into a benign state, but that tends to be costly. Costly in the sense that it takes longer to run the activities between test cases. And you still are unable in that case to run two of these test cases in parallel because you can't reset in between them. Another option would be to ensure that our test cases take responsibility for the data that they're going to use to test, this Oracle data or the data that they're modifying or whatever, in order to test the activities going on within our system. And that can be quite helpful if we create useful, unique data for each potential test case. And when that's the case, when it's unique, we're no longer tied together, so we would have solved the problem. There are many different methods for how to do this, and I go through them in those webinars I mentioned earlier. The main thing we're trying to get out of this here, if you take nothing else away from this particular slide, remember, isolate your test cases. Try not to have dependencies on them, because we want to be able to run these tests in parallel. We want to be able to run each test repeatedly without other tests running before them. We want to make sure that when we look at a report of tests, we know that each test failed for a given reason, and not because of other test cases and the activities that they did. We want to make sure that we can run these from many different users, from many different client machines, or if that's a web app or whatever. It's usually a good practice. It's almost always a good practice to isolate your test cases. Pass or fail only. I see this quite a bit. I walk into organizations and I see that we've got continuous integration running, which is terrific. We've got a bunch of test cases running, which is great. We have these red ones. That means that everything failed. I always know red means something failed, right? Green, these are all the ones that pass. Great, I know what green means. And then sometimes I see other colors like blue and yellow and purple and stuff. And I say, what is the status of that test case? What's the status of the execution of that? What did it mean for it to run? And I get these different answers. And sometimes a yellow might mean that this is a test case that failed originally when it ran, and then the next 2 times it passed. So that might mean what yellow is at that organization. And I might ask about purple, and they'll say, well, purple means that that test case is not done yet. It works up to a point, but we haven't finished developing it. We've noted it as being under development, and we're not going to run it all the time. It doesn't always do what it's supposed to do, and it's not done. And you might see lots and lots of test cases in either of these situations. And my belief is that the way that we provide helpful information about the system under test, and I feel like that's the job of a tester, is to be able to give accurate information on the status of the system under test, to communicate that information effectively, and then sometimes we're able to identify risks, and sometimes we're able to communicate what the impact of a risk might be. Those are kind of bonus points for me. But basically, we're trying to communicate the status of a system under test. What does it actually do? How does it actually work in the real world? And so when I'm writing test automation, that's what I'm thinking. And when we're looking at a set of reports from a system that's run test automation, and we can look down it quickly and understand test cases 4 through 7 passed, test cases 25 through 30 failed, and I know passed or failed, then I know what parts of the system work or not. All the rest is just noise. It's just messy noise. And to me personally, the fact that something ran once and didn't run the next 3 times, I don't care about that. That's not the status of the test case right now. The status right now is that it doesn't work. If it fails 3 times and runs once, it doesn't work. It should be red. And generally, when a test case has that type of situation, we've got one of several things happening. Usually, we're either, once again, competing for resources, and the 1 out of 3 times that it passes, or 1 out of 4 times it passes, it gains that resource and kind of gets a lock on it and is able to use it. It could be something where the test case is just written poorly and we don't have our weight conditions set up properly in certain areas of the test case. So because of timing issues or whatever, we've got a test that works sometimes and not others. Basically, you've got a test case that hasn't been written well, or could be more robust, or it's giving us faulty information. And these test cases, the test automation that we write, we want it to be credible, we want it to be accurate, we want it to be precise, we want it to be clear. We want it to communicate effectively and directly. So when something's working, sometimes not others, that's a failure on our part as test automation engineers. And those are test cases that we need to take back, usually either move them out of, and I say usually a lot, but we either need to take them out of the suite that they're in right now and not expose them to people because they're not giving us helpful information. They're not giving the developers or the stakeholders helpful information. They're giving us as test automation engineers helpful information. And that's a different user of the system. That's a different user of the test automation. So when we have those situations, they should be internal to test automation. And we should be looking at them and saying, okay, how do I as a test automation engineer make this so that it's more helpful to my customers over here? I want it to either pass every time or fail every time, right? I want it to be robust and solid. So the case of something running sometimes and not others, that's not one that I like to see shown in reports from continuous integration or anything like that. It's one that I like to see pulled back into the test automation world, and we work on together until it's robust and ready to go. The case of developing test cases, I like to see stuff checked in when it works. I understand that there are cases where we have large test cases or we need to work over them on certain more than one day, but then they need to be excluded from your test run. Once again, in most cases, we don't necessarily want developed test cases in there. That's just noisy. And if I see a report where things aren't developed, that's a failed test, and that's something that needs to be looked into. It's a failed part of our process. Why do we have test cases that are checked in, that are being executed if they're not done? What value are they giving us if they're saying, I'm not done, instead of this passed or this failed? I want to see passed or failed each time for each test. The other thing that goes on with these is I see a whole lot of them in some organizations. And what that indicates to me is we have a hard time finishing one thing before moving on to the next. And one of the key components of Agile and of some of these methodologies is taking something to its final end, is finishing something. If development is going to have a definition of done, we need one in test as well. Test automation engineers, it's okay to check one in every once in a while, but don't be all over the place trying to write 5 different test cases. You can't do it. The human brain is not set up to multitask with conscious level activities. We don't do it well. I know that people think they do, but what I see is a bunch of distraction and poor thinking. I see people who execute very poorly when they're trying to do more than one thing at a time. Very, very, very rarely do I ever see anybody who can actually do more than one thing at a time well. So finish your test cases, then move on to the next one. I don't want to see a whole bunch of purple tests all over the place. Fail for one and only one reason. So I really liked this design, this pattern, this image, because it's hard to look at. It's hard to know what's going on in it, but yet it's fascinating. And you know, I see a lot of reports from test automation that look like this, where we get back a report and we have a test case that's failed, and we start looking into it and we're verifying 25, 30 different things. We've gone over this long set of verification points and processes and activities in our system under test. And as we look through them with our test case, it becomes unclear to us as test automation engineers what it is that we intended to do with the test case. Why did we intend to write this test? What was the purpose of it? So I like to have test cases that fail for one and only one reason. And I hear what you're saying. Okay, well, I've got a really long E to E test, and it tests, submitting a CSV file to the system, and it goes through the system, and there's processing that's done, and the numbers are changed, and we've done computations on them, and then after that massaging of data and whatever we've done, we take that data and put it in a different format like JSON, and then we send it to the right user, and they get it. I want to make sure that all those steps work. Well, of course, we all want to make sure that all those steps work. But I like a test case set up so that if it's the end-to-end test, my verification is that basically when I put information in that activity, it's verified when the right person gets it and it has the right info in it. Okay, that's my verification point over here. And then I'll break down smaller tests that'll go in and make sure that we know how to upload a file. And the only verification point there, the only failure that we could have is whether or not the file is uploaded, right? We check the database, or we check memory, or whatever it is to make sure that the file is uploaded. When we do processing, I want to check that when we insert data into the processing mechanism, we get the right thing out of it, okay? So that would be another test case that can fail for one and only one reason. When we go through and we change the format to JSON, and we persist this into JSON, I want to know that the format of the JSON is correct. And then when we send it to the right person, did we actually send it to the right person? Another test case might verify, did we get the right thing back? And by doing that, what we start to see is we have much smaller test cases. We may have that overarching one that still, maybe it still takes a long time, but when we look at it, we know for a fact we didn't get from end A to end Z. We didn't get end to end. That's all I want to know. We didn't get there. And then this other level of test is going to inform us about what actually didn't work. So if I'm looking at a report and I see that that high level end-to-end test didn't work, I can look at these other test cases and say, well, it didn't work because the upload didn't work. All the other pieces of this work fine, but the upload didn't work. And oh, by the way, I'm in continuous integration and in my continuous integration system, and I can see on there that there was a commit from whoever, George or John or Ringo or Paul or whoever, whichever beetle made the commit, and that particular individual was working on upload features. So that would be the first person that I talk to about this, right? And maybe they even get notified when the test case fails with those results, and they can see right away what's going on. When you have a test case that is failing for one and only one reason, you can also name it very, very clearly. I understand traceability is important. There are lots of other ways to do traceability than having a test case with a name like 1, 2, 4, 5, 6, right? You can name it upload of CSV file, right? Or download of JSON file, or processing of, of silly data, or whatever it's called, right? But something that means something to you and means something to users, something that when you read the name of that and it comes out in your test results, you know immediately if that test fails, that's the reason why, and the title tells me, and I know what I can do and who I need to talk to get that resolved quickly. We're all working on the same team here. Most of our purposes are trying to get development and to get software out to our users as quickly as possible so that we can compete in the marketplace faster than our competitors, so that we can interact with our users more quickly and deliver functionality that they need in order to increase our market share or to increase the betterment of their lives, or whatever it is we're trying to do within our organizations. But we're trying to speed the cycle up of getting development out as testers, that we want to be a part of that. Number 4, developers can run tests. This is something that I think is overlooked again and again and again. I just saw on Twitter, one of my followers and somebody who listened to this originally this morning as I was doing it live said, you're blowing people's minds with what you said, with what I'm about to say here. As a tester, as a test automation engineer, one of my biggest customers is developers. It's one of my biggest customers. I think of them as a customer because I'm providing feedback to them about their software. That's one of my biggest jobs. I want to make sure that when they get information from me, they're getting really great information. I'm delivering it in a concise manner, and I'm doing it accurately and with credibility, that they can trust me and trust the information that I'm giving back to them. So when I'm writing test automation, and I've said this before in other webinars, if you go back, if you look through a bunch of them, or if you haven't, go back to beaufortfairmont.com/webinars and look at the one entitled, what do we test first, or what test do we create first? I think it's one of those is the name of it. And one of the patterns that I talk about in there for making test automation work is taking small steps, taking baby steps as we're creating test automation. So I would envision within an organization with no test automation at all, find something, the smallest thing that you can write a test case for, get it to run on your system as a tester, get it to run on your neighbor tester's machine, figure out what the difference is between the machines and identify the problems with configuration or or environment or whatever, isolate what those are, figure out how to get through that with by pressing a button instead of configuring it yourself. And once that's done, go to a developer and try to run this on their machine. And if they can run it on their machine and it works, then you get it together and you say, okay, I know how to write a test, I know how to do the configuration and everything else for everybody that's going to use these things. And now I'm going to commit it, I'm going to make sure that it works in my continuous integration system or some system of truth, some source of truth out there. But we want to make sure that developers can run our tests, because we're trying to take that feedback loop that continuous integration is meant for, and we're trying to make it as small as possible. So I want to know that a developer can run a test. As a developer, I loved being able to do that, to take a UI test or an integration test or whatever it was and run it on my system. It helps me be able to debug into the problem code, to see exactly what's going on, to go through that path of code. That saves an enormous amount of time if a developer can actually see it running, debug into the actual code, and see where the problem is. So that's what we want to do, because we're all working together to try to get development of software faster. We're not here to be gatekeepers in most cases. Some cases we are, but not in most cases. Most cases we want to be enablers of the software development process. And as testers, we need to find ways to do that, because the market is going to run away from us if we don't. Use continuous integration. I got to tell you, this is like malpractice in 2017. If you're not doing continuous integration within your development environments, there are generally very few good reasons to not do it. I rarely hear a good reason not to do it. I hear we don't have the skills to do it, and in that case we can help you out. In that case there are developers who can help you out, whatever it is. I hear cases where testers are not running test automation within continuous integration, and there can be good and bad reasons for that. But for the most part, we need to be doing this. This is like washing your hands as a doctor, or putting on latex gloves as a doctor before going into surgery. Let's practice continuous integration. Let's find ways to get our test automation running in continuous integration. Because once again, as with a developer being a customer, we're trying to make sure that the lag time between the time that they create something and the time that we tell them there's a problem with it is as short as possible. What happens in software development is that developers have to spend a lot of time focused on one problem. And when they get away from it, they take all of that focus and they throw it out the door, and they go on to take all of their energy and focus on the very next thing. Okay? So if it takes 2 weeks between testing a piece of code and writing a piece of code, that makes it so the developer has to spend a lot more time getting back into understanding what they've done in the past, understanding the code that's there, and syncing that back up, caching it back up in their head to understand what the problem is and what they did before. I can tell you many times, I write something and 2 weeks later, I go back to that code, I don't know what I did. I don't understand why I did it. A year later, that's even worse, right? But if I'm in that code still working on it and somebody's written a test right away that was ready to go the second I committed my code, I know immediately. I've still got that cached up. I still understand the decisions that I made. I still understand why the code's there and where the problem's going to be. And that saves just a tremendous amount of time when you replicate that over developer, over team, within your process. So we want to get test automation written early. We want to make it available to developers to run in continuous integration. We want to make sure we as test automation engineers are running these tests often, because the system's going to change, and we want to know how our tests need to change as well, right? So it's important for us too. We also want to know if our tests work, okay? So we run them often to make sure that we've taken care of as many situations as possible and our test automation is robust as possible. This is one of my favorites. So when I originally did this talk, I did this for the first time back in 2013, and it was one of the first talks that I did about test automation. And I took 9 ideas, 9 patterns for test automation. You can still go and look up the video of that on my LinkedIn profile. It's Paul Merrill on LinkedIn. And you can watch it there. I had a little bit shorter hair at the time. I was a little bit younger, but it's 3 or 4 years ago. And I really, this is one of my favorite presentations. But as I went back and kind of reflected on this and thought about the things that were the most important, I threw some of those ideas out. They're still important to me, and I don't necessarily reject everything that I said on there, but these were the 6 most important. It's actually 5 of those 9 that you've heard here so far. And this number 6 is one that I didn't include in that group. And over the past 4 years, it's become more and more important to me what the intention is of our testing. So I work with lots of different companies. And my consultants, my team works with lots of different companies. And when we go in, we need to know why we're doing what we're doing. And a lot of why we're doing what we're doing is built on automatic assumptions, on things that we just know within our organizations. So these clients, there are things that they know. And when I ask them, why are you doing testing? They think I'm stupid for asking the question. That's okay. They can think I'm stupid all they want. It doesn't affect me. The question stands. Why are you doing testing? Have you thought about it recently? Have you thought about why you're testing, what you're testing with your organization? Have you gone through your test suites, whether they're manual or automated, and thought about why are we running these particular tests? What risks are we identifying with these tests? What are we checking? Is it important to continue checking this? Do we still even have this feature or this functionality? What is the intention of your testing? And then secondly, I like to ask clients, what's the intention of their test automation? Why are they doing test automation? And a lot of people think the only reason to do test automation is to save on labor, so that the people who are manually going in and testing things today, that are manually going in and going through scripts, can use their time in other ways. I think there's a lot of reasons to do test automation. We may want to do it because it's consistent over time. Humans get tired of doing the same thing again and again, and they skip steps. Computer won't do that. We may have large, complicated calculations that we want to do. Humans aren't as good with that as machines are, especially doing them repeatedly and repeatedly correctly. So there are lots of reasons to do test automation. I remember an example of a client company that we were working with, and they had a system that was a web application, and when we went in, we made sure that all the pages came up first, that we always could get certain pages. Manager came back and says, why would you be doing that? I don't care if the pages come up. I care if the numbers are right on the pages. I thought, wait a minute, don't you need the page to come up to know if the number is right on the page? He says, no. What we need to know is it's more important to me. I would rather the page be down, the website be down, than have the wrong numbers on the page. So there are these fundamental assumptions that we can make over time. We need to go back and assess them every once in a while and find out, are these intentions still here? Is this the reasoning why we're doing this? What are we thinking when we're doing these tests, and why are we doing these tests? So make sure you're guided by intention when you're doing test automation and when you're doing testing. So here are a few references I used in this. David Cobb was about the learning styles and experiential learning. I'm always willing to share my slides if you just send me an email. Here's my email address here, Paul, during that last section of code, or last section of text there, paul@beaufortfairmont.com. Reach out to me there. This is our office number. We're not always able to answer the phone. We're a small company. But if you call us and you leave a message, we will get back to you as soon as possible. Let us know your phone number, why you're calling, that kind of thing. Hopefully you found us through beaufortfairmont.com/webinars. If you didn't, go to that page. There are more webinars available, more recordings just like this one. Hopefully the content is high quality. Hopefully you get out of it as much as you've gotten from this one or more. But those are always available, the recordings there. I've been doing these since August. I posted every one of them since August, so there should be 8 or 9 of them there available for you today. Reach out to me. Oh, and also you can sign up to learn more about our webinars. So there's a link on there. If you're watching this with a friend or whatever and you want to be notified when the next one is coming, go there. And a shortcut is bftft.com/webinars. So go there, click on the button that says sign up to learn about our webinars when they're happening. We will email you when these are upcoming. You've got my email address there. You've got my Twitter handle. Please make sure to follow me on Twitter. I like to tweet about testing. You can hit me up there with questions about testing or test automation or thoughts or what you want my thoughts on or whatever. I do a podcast called Reflection as a Service. Reflection as a Service is about software engineering and entrepreneurship, 2 subjects that are close to my heart, close to my career. And we talk about one of those 2 subjects each time we talk. We try to do that twice a month. Every once in a while, we may not get something out, but we try to get something out on the 1st and 15th of every month about one of those 2 topics. So once again, this is us. We're Beaufort Fairmont. We help teams accelerate their test automation. I hope that you've enjoyed this and that it's been informative. Make sure if you're going to be at any testing conferences coming up, keep an eye out for me. Once again, I'll be at Tri-Agile in the next couple weeks here in April 2017. I'll be at a number of other conferences around. I'll be at Star West out in Anaheim in October, and there are several other things coming up on the schedule soon that I'll be at. So Please make sure to look me up if you're going to be one of those. Stop me and say hi. Let's talk about your testing and what's going on. You can always call me. The first case is always free. Let's talk about what's going on within your test automation environment. If there's anything I can do to help talk about your challenges, we'll do it. And if we need to do more work together, we can do that too. We're always looking for new clients and for new challenges with test automation, so bring us yours. Thank you so much for your time, and I look forward to meeting you and to getting to know you over time. Thank you.